Chapter 6 Supplement Statistical Process Control. In this chapter, we're going to look at three concepts. One is statistical process control, then process capability, and acceptance sampling. Statistical process control is a mechanism by which we try to get a statistical signal when there is assignable causes present in the production process. Now, what is assignable causes? Okay, we'll talk about that in just a few minutes. Now, variability in a production process is inevitable. Okay, however perfect an operation may run, it will still have some amount of variability. For example, if you're talking about cereal manufacturing company, so they put cereal in cereal boxes and supposed to weigh 16 ounces, then you're not going to have exactly 16 ounces in each and every box that comes out of the filling machine. So there's going to be slight variability from box to box. Now that is called natural or common causes variability. Variability that is attributable to natural variations. But if the production process is not operating the way it is supposed to, and if there is a problem in the production process, then that may cause some variability in the measurements, or in the case of cereal manufacturing, the differences that you see in the weights are probably due to some problem in the production process that should be corrected. Okay, variability attributable to correctable problems in the production process. Okay, those are called assignable cause variation. Variations due to assignable causes. So statistical process control is a statistical signal to indicate when assignable causes are present. That is the primary objective of statistical process control. Now, most of the times it will be these assignable causes are causes that are causing problems, so it must be eliminated. The assignable cause may be a good cause. Maybe the process is operating better than what you normally can expect. In such instances, also you want to study that not for the purpose of eliminating those good assignable causes, but to make it part of the production process, so the benefit can be derived. We can continue to derive the benefits. So natural variations or common causes, they're actually present in every production process. It cannot be eliminated. You have to expect a certain amount of variability due to natural variabilities, natural causes. Now, output measures always follow some sort of probability distribution, and those probability distributions will have a central tendency. Okay, the values fluctuating around a central value. If the distribution of output falls within the acceptable limits, then the process is said to be in control. That is, this in control phrase has a very particular technical meaning, and that is, if the production process contains only natural variations, okay, variations that are attributable to common causes, then the production process is said to be in control. If there is assignable causes present, then the production process is not in control. So assignable variations, also called special causes of variation. So generally this is production process has changed from what has been set, what is normal conditions of operation. So variations that can be traced to specific reasons, okay, and these could be bad reasons, in which case you eliminate. If these are good causes, then you want to replicate it or make it part of the production process. Now, we do this by taking samples. So to measure the process whether it is in control or not, we're going to do that by taking samples from the production process. So if you're talking about cereal manufacturing and you take samples of the product from the filling machine, say for example 5 boxes, 6 boxes, the number of boxes that you select or sample size here need not be really large, because we're going to be taking repeated samples over time, and therefore small sample size is not a big problem. And then you weigh each sample and find the average. So if you plot the average weight, and you will find a curve something like this. When you plot the averages, the X bars, you'll see normal distribution. After enough samples are taken, okay, not just one or two samples, but several samples, then you will see the distribution taking shape. If it is operating properly, if it is in control, then the pattern of the distribution will be something like this. Now here is a graphical representation of a production process that is in control. Only natural variability, then you're going to see a very stable production process. Each instance need not be exactly at the center. No, there may be variations, but it will all be predictable type of variation. So in the future you can expect the production process to be stable. But if the production process is not stable, if there are assignable causes present, then things could be something like this. The distribution shifts to the right, or it becomes flatter and has more variability, and the prediction becomes inaccurate or problematic, becomes unpredictable. Production process, where will it go? Where does it go? We don't know. So control charts are used to detect those variabilities that tend to be unpredictable. So you construct a lower limit and an upper limit and a target value at the center, and then you plot the X bars as you take each sample, compute X bar and plot them. So this is how the control chart will look like. And if the values, the X bar values fall within the control limits, then the process is said to be in control. But if it falls outside, or if there are any special patterns that you see, which are called run tests, we'll look at them a little later, then you suspect assignable causes. Okay, so here is lower limit and upper limit, and if the production process is in control, you're going to see a process something like this, a statistical control and capable of producing within the control limits. In the second case, it is statistically in control because the target value doesn't shift to the left or to the right, but then the range becomes larger, or variance is larger, and you have large parts of the tail falling outside the control limits. Or in the third case, the central value itself is outside the limits. So the process is said to be out of control now.